used a LDR sensor, one touch sensor, two LEDs, one buzzer, one Arduino, one ultrasonic sensor, one battery holder, two batteries, one transceiver NRF 24801 module, one motor driver string, and USB cable and one power bank. Indicator. This is my voltage indicator. This is my wand. When it presses continuously, it keep like this. Now, if I touch this card, this will go like this. I put light to this card, the headlight will turn off. This is a remote control card with advanced safety features and power saving. Just stick in front of this card, the buzzer will beep. Forward to this card. If it right to this card will be right, and if left to this card, the card will go left. Now if I stay in front of this card and be forward, the motor will never move. I have used one looping library, one SPI library, one NRF 24L01 library, one RF24 library, and I have declared the buzzer as A0, LED1 as A1, LED2 as A2. Then I have declared ABC as 3 variables. Then I have declared the motor pins as L1 2, L2 7, R3 4, R4 5. Then I have declared the enable pins as PWM pins. ENA is to 3 and ENB is to 6. Then I have declared 4 variables named IGPK. And I have declared the trigger and echo pin of this ultrasonic sensor. Those are A5 and A4. Then I have declared a variable name distance. I have initially kept it as 100. Then I have given the maximum distance as 600. Then I have created the object named sonar for the looping, which contains streak, echo, maximum distance. Then the CE pin of the transmitter, transceiver. So which is now receiving the data. I have declared as C pin of 10, then the CS pin as 9. I have created the RF24 object, which is I have given a RF24 radio C pin, then CSN pin, which I have declared just here as 9, and I have given a byte address. I can give any path. I have given 5-digit path, actually 5 byte 00 0. I have given as 4 zeros and 1. Then I have, in coming to the void setup, I have declared in when I have declared the pin number 8 as input. Then A3, 8 means the touch sensor, actually. The A3 as input, which is the LDR, trig as output, echo as input is for the ultrasonic sensor. Then I have begin the serial communication from the laptop to the Arduino board in 9600 baud, and I have given a radio.begin function. Then for beginning the radio, then it is the open routing 5 function, where I have given as 0 comma the address. Then I have set PA level as I have set the PA level as minimum. Then I have used the radio to start listening. Then I have put the enable all the motor pins, actually including enable pins, to output. Then the buzzer LEDs as output. Coming to the void loop, I have read the value of the touch sensor and LDR by A and B variable. Then I have printed LDR. Then I have give the variable for the reading the value of LDR. Then I have declared the distance as readping. Readping is a function and letter. And then I have given the serial.println distance for the distance. Then println distance, which is the variable. Then delay of 300 milliseconds. And then the radio dot available function. If radio dot available, it will declare a character as comment. Then it will read the radio as it is the function and command in size of command. And then I have declared a switch for command, in which I have declared first as case if. Then I have printed forward. Then if distance less than 40, it will print stop. Then the R3 pin will be low, R4 will be low, all the pins will be low. And I will give the delay of 100 milliseconds. Then if distance greater than equals to 40, it will L1 as high, L2 as low, R3 as high, R4 as low. Then the analog write function for the enable pins, I have set it as 1 speed. Then I have given the delay of 1 second. Then it will stop. Then I have given the delay of 100 milliseconds and it will break. In this case, I am going to the case backward. It will print the backward word. Then L1 as low, L2 as high, R3 as low, and R4 as high. Then the analog writes enable pin 1 and enable pin B, enable pin A and enable pin B as speed 1. Then delay of 1000 milliseconds, which is equals to 1 second. Then it will stop the car as forward. Then it will break the case. Then coming to the right, it will print right. Then R3 as high, R4 as low, L1 as high, L1 as low, actually, and L2 as high. Then it will keep the enable pins as 1 1. Then it will give a delay of 100 milliseconds. Then and will make the high low for forward, but enable pins as 1 1 for 1 speed. Then it will give a delay of 150 milliseconds. Then it will again give the same as stop, which is in the forward and backward. Then I have the delay of 100 milliseconds, and then break. Now this is for the left, which I have printed the left. Then R3 as low, R4 as high, L1 as high, and L2 as low. Then the enable pins as 1 and 1 for the speed 1. Then a delay of 100 milliseconds. Then I have put it in digital right, L1 as high, L2 as low, L3 R3 as high, R4 as low. Then analog right, ENA and ENB as 1. This is for this speed, this is for this set speed as 1. And then a delay of 150 milliseconds. Then it will again do the same of every stop, then break. Then this is the stop case S, which is in the if the joystick is in the middle condition. Then for the buzzer, case G will will make the buzzer pin high. Then it will print buzz. Then it will give a delay of 100 milliseconds. Then it will make a variable named I. Then it will plus the value of the variable I. Then it will break. Then where did it go? Then case H, where it will run a for loop less than 10. It will make the LED 1 high, then LED 1 low for the blinking. Then again delay 100 milliseconds. Before this is also delay 100 milliseconds. It will print LED 1. Then it will break the case. Then going to the I, it will again run a for loop for 10 times actually. Then LED 2 high, then delay 100 seconds, then 100 milliseconds actually. Then LED 2 as low, then again delay of 100 milliseconds. Then it will print LED 2. Then it will break the case. Then case J, I have even a label as label, where I have given digital light LED 1 as high, LED 2 as high. Then it will make the K variable plus 1. Then it will print LED, which is for the headline. And we could use that for making the light once off. If we press this button, I will show this feature later on after explaining this code. Then if I by 2 not equals to 0 means the button is pressed one time, the buzzer will be low. If one time or not a even number, then k percentage 2 actually, k percentage 2 not equals to 0. Now 0 which will give the headlights off. Then it will go to the level function. Then if a equals to 1, which is for the touch sensor, it will make a equals to 0. Then a less than 50. If a less than 50, to 0. If a less than equals to 50, a will be plus. Then digital light buzzer and LED 1 is high. Then delay of 100 milliseconds. Then digital light LED 1 has low and LED 2 is high. Then a delay of 100 milliseconds. Then it will make the LED 2 as low. Then if B is greater than equals to 300 for the LDR, and it will make the digital light LED 1 as low, LED 2 as low. If B less than 200, the LED 1 and 2 will be high. If distance less than 40, the buzzer will be high in the delay of 100 milliseconds. If distance greater than 40, the buzzer will be low. Then I have given a delay of 100 milliseconds. Then I have given return distance. This is the second bucket for the void loop. This is the read ping function, which is first give a delay of 100 milliseconds. Then it will name a variable named cm equals to sonar.ping centimeter. If cm equals to 0, if the cm will be 0, then it will make the centimeter as 250 and it will return the cm, and it is the function for read pin. Then I am moving to the transmitter code. It will include SPI library, then nrf24l01.h, then rf24.h, then it will get the button pins in the joystick shield 2, 3, 4, 5, then the joystick X and Y as A0 and A1, which is for the joystick shield. Then it will define the NRF24L01 pins, which is C pins equals to C pin is 9, CSN pin is 10. Then it will create a radio RF24 object name radio. Then it will again declare the object, the address actually 000, 4 zeros and 1. In void setup it will begin the serial communication, and then the radio.begin, then open writing pipe is address, then the PA level as minimum, then it will stop the listening. Because it is a trans receiver module, I have to open the listen, I have to start the listening and stop the listening. Then the joystick pins as input pull up, then the button pins as also input pull up. Then it will read the joystick values using the analog read functions and store it in X value and Y value. Then it will give a delay of 200 milliseconds, then and it will read all the buttons value, then it will print just X value, then Y value, Y value, then the Y value. If Y value greater than equals to 50 and then Y value less than 800, then it will send command F. The send command is a function and it will send the command F. In else if Y value less than 200 and Y value greater than equals to 0, it will go to the send command function and send a B. Then else if X value greater than 500 and then X value less than 800, it will go to the send command and send R. Then else if X value less than equals to 200 and then X value greater than equals to 0, it will go to the send command function and send L. Then else if A equals to 0, it will go to the send command and send G, and serial print also G. Then B equals to 0, it will send command H and serial print H. If C equals to 0, it will send command I, then serial print I. If D equals to 0, and then send command J and serial print J. Else it will send command S. The void send command, I have used chart command or command character command. Actually chart equals to character in this language. Then radio.write and command comma size of command, it will write command in size of command, then delay of 300 milliseconds. Then it will close the void loop. Void for this now that feature, so I use undo. This is the feature. This pressed. This is pressed, but I will pause. Then this switches. This switch is open.